What's up guys, and welcome to this video. We are going over the 2017 November AP Maths exam. Okay, so as per usual, I am going to seek out one of the easiest questions, which is usually the proof by induction. Okay, mostly because it's a place where you can get your quick marks, and it's always bound to come up. So we are doing question 4. Okay, so it says, prove by mathematical induction that 1 minus 1 over 4 times 1 minus 1 over 9 times whatever times 1 minus 1 over n squared is equal to n plus 1 over 2n. And the restriction is for n is greater than 2. Okay, so basically we need to start off by stating what we want to prove. So firstly we can say we want to prove that. Okay, so another thing to note is that we can probably change this to 3 over 4 and what's that, 8 over 9, etc. But if they give it to us in this form, it's probably easier to use it in this form. So always start off by giving or trying to work with it in that form. So I'm going to say 1 minus 1 over 4 times 1 minus 1 over 9 times 1 minus 1 over 16 dot 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 all the way to 1 minus 1 over n squared is equal to n plus 1 over 2n. Okay, so that's what we want to prove. Then the second thing we do is that we prove true for n equals, okay, so usually we say n equals 1, but in this case we're going to say n equals 2 because of our restriction. So n equals 2. So if we look at the last term, what we have is the left-hand side is equal to 1 minus 1 over n squared, or 2 squared rather, 2 squared, so that's equal to 1 minus 1 over 4, which is equal to 3 over 4. And then if we look at our right-hand side, okay, so remember I'm denoting this my left-hand side and this my right-hand side. So my right-hand side equals n, which is 2 plus 1 over 2 times n, which is 2 times 2, which is equal to 3 over 4. Therefore, we have proven true for n equals 1. Okay, then our third step is that we assume that the statement is true for n equals k. So we're going to say that 1 minus 1 over 4 times 1 minus 1 over 9 times all the way to 1 minus 1 over, instead of n, I'm going to say k squared is equal to k plus 1 over 2k. Okay, so my next step, step 4, is going to be to prove true, or prove that the statement is true for n equals k plus 1. Okay, so my required to prove is going to be basically that 1 minus 1 over 4 times 1 minus 1 over 9, all the good stuff, my last term. So my last term is going to be, so this is, my last term is going to be 1 minus 1 over k plus 1, and all of that squared, including the brackets, is equal to 2 times, not 2 times, but rather k plus 1 plus 1, so k plus 2 over 2 times k plus 1. Okay, so that's what I want to prove. So I'm going to start off with my left-hand side. So my left-hand side says that 1 minus 1 over 4 times 1 minus 1 over 9, all the good stuff, and then my last term is equal to 1 minus 1 over k plus 1 squared. But what's the term right before that? The term right before that is 1 minus 1 over k squared. Okay, and if we look at this, all of this right here is the same as our assumed statement, or the left-hand side of our assumed statement. So all of that becomes k plus 1 over 2k times k, and then I'm going to say that's k plus 1 squared minus 1 over k plus 1 squared. Okay, now we just need to clean this up a bit. So what we're going to have is we're going to have k plus 1 over 2k all multiplied by k squared plus 2k. Okay, I'm going to get a plus 1 and then minus 1, so I'm going to just leave that out, over k plus 1 squared. Okay, this k plus 1 cancels with that one of those k plus 1s, so that falls away. I'm going to factorize the top, so I'm left with 1 over 2k times, take out a k plus 2 over k plus 1. Okay, these two k's cancel, and what we're left with, our final left-hand side, is equal to k plus 2 over 2 times k plus 1. Okay, which is equal to, so our left-hand side equals our right-hand side. Okay, so what we can say is our final closing statement, so the last thing, therefore, we can say we have proved by mathematical induction that the result is true for, and then what is our restriction? N is greater than equal to 2. Okay, so yeah, that's basically that question done. So I hope you guys were able to follow the steps. Basically every single proof by induction, we follow these 5 steps, and we end up getting a nice 12 marks. So yeah, thanks for watching guys, and I hope you found this useful.